Welcome everyone to today's exploration into the heart of computer science, the stack, a journey into the last in, first out. I am Japjot Singh, and in the next few minutes we'll unravel the secrets of the fundamental concepts in programming, the stack. Imagine a world where the sequence in which you do things matter, but the last action you take is the first to be undone. The world is the world of stacks, and today we're going to navigate through its intricacies. In this journey, we'll begin by defining what a stack is and why it's a critical element in the toolkit of every programmer. We'll dwell into its components, operations, and the various ways we can implement this powerful data structure. As we progress, we'll explore the role of stack in managing memory, particularly in the context of function calls and returns. We'll also peek into the hardware level to understand how processors leverage stacks for efficient execution. But it doesn't end up here. Stacks are not just theoretical concepts, they find practical applications in various aspects of computing, from managing function calls to evaluating mathematical expressions and even powering undo mechanisms in software. Stacks are ubiquitous. However, with great power comes great responsibility as well. We'll discuss the common mistakes and issues related to stacks as well, ensuring you're equipped to write robust and error-free code. By the end of our journey, you'll not only have a deeper understanding of the stack, but also appreciate its role in shaping the way we design our algorithms, write software, and even with hardware systems. So, fasten our seatbelts as we embark on this enlightening voyage into the realm of stacks. Standing stacks, a journey into the last in and first out, starts now. Stack Unveiled Fundamentals. So, hi everyone, welcome to today's presentation where we embark on a journey to unravel the mysteries of one of the fundamental concepts in computer science, the stack. I'm Japjot Singh, and today we'll dwell into the world of stacks, exploring their structure, operations, and applications. So, let's dive in and get a deeper understanding of last in, first out, magic that powers many aspects of computing. Buckle up for understanding the stack, into the last in and first out. Introduction to stacks. Definition: a stack is a fundamental data structure characterized by its last in, first out behavior. In simple terms, think of it as a stack of plates, but above it, the last plate you put on the stack is the very first one you take off. Today, we'll explore why this structure is crucial in computer science and programming, understanding its role as a powerful tool in managing data and process. So, why a stack? The need for the structure. The question arises, why do we need a data structure like a stack? Consider scenarios where we want to keep track of things in a specific order, especially when it comes to managing process. Stacks offer a simple and efficient way to handle this order, making them indispensable in various applications. Let's explore why this stack is not just a theoretical concept, but a practical necessity in the world of computing. Components of a stack. Operations. At the core of a stack are two primary operations, push and pop. Think of a stack as a collection of items, where pushing adds an item to top and popping removes the top item. This last in first out behavior is central to the stack's functionality. To visualize, picture a stack of books. You add a book on the top, and the one you grab first is the last that is placed. The stack pointer keeps a track of the top position. Stack implementation. Using data structures, a stack can be implemented using different data structures, with the most common being arrays and linked list. Both implementations have the merits. Arrays are simple and provide constant time access, while linked lists offer dynamic memory management. Understanding these implementations helps us choose the right tool for the job. Let's explore how these structures bring the stack concept to life in programming. Stack memory. Call stack in programming. In programming languages, a stack is closely tied to the function calls in memory management. As functions are called, local variables, return addresses, and other crucial information are stored in the stack memory. This mechanism is vital for maintaining the flow of execution, especially when dealing with nested function calls and recursion. Let's dive into the call stack and understand how it plays a pivotal role in the execution of programs. Applications of Stack. Versatile applications. Stacks find application in diverse areas within computer science, showcasing their functionality and versatility. Function calls and recursion. Understand Stack manages function calls, enabling smooth execution and return. Expression evaluation. Postfix notation. Explore how stacks simplify mathematical express evaluation. Undo mechanisms in software. Learn how stacks empower the undo feature, a common functionality in every software that we use in our day-to-day lives. Backtracking algorithms. Discover how stacks facilitate efficient backtracking and algorithmic problem solving. By exploring these applications, we see how the stack, with its last in and first out behavior, becomes an essential tool in the programmer's toolkit. Common mistakes and issues. Stack overflow and underflow. While stacks are powerful, understanding their limitations is crucial to avoid common pitfalls. Stack overflow. Exploring scenarios. Common mistakes and issues. Stack overflow and underflow. While stacks are powerful, understanding their limitations is crucial to avoiding common pitfalls. Stack overflow. Exploring scenarios where the stack becomes too full, causing a stack overflow. Discuss the impact on program execution and strategies to mitigate stack underflow. Examine situations where attempting to pop from an empty stack results in a stack underflow. Share the preventive measures and handling techniques. Understanding these issues enhance ability to write robust code that leverages the advantages of stacks without encountering runtime errors. Stack and hardware. Hardware integration. The stack concept extends beyond software and plays a significant role in computers' hardware. Processor functionality. Delve into how it's utilized a stack for managing function calls and returns. Memory management. Explore the connection between hardware memory and the stack, highlighting the efficient use of resources. Understanding the integration of stacks at the hardware level provides insights into the seamless interaction between software and hardware components in modern computing systems. Conclusion. Key takeaways. Recap the fundamental properties of a stack. Last in first out. LIFO. Highlighting the significance of stacks in programming and computer science. In conclusion, we have unraveled the mystery behind stacks, a simple yet powerful data structure that forms the backbone of many computational processes, from managing functional calls to enabling the efficient algorithm, from maintaining conclusion. Key takeaways. Recap the fundamental properties of a stack. Last in, first out, LIFO for short, highlighting the significance of stacks in programming and computer science. In conclusion, we have unraveled the mystery behind stacks, the simple yet powerful data structure that forms the backbone of many computational processes, from managing function calls to enabling efficient algorithms. The stack's versatility makes it an indispensable tool for every programmer. As we continue our journey in coding and problem solving, keep in mind that your stack's unique characteristics and explore ways to leverage its power in your projects. Thank you for joining me on this exploration of understanding the stack, a journey into the last in and first out. If you have any questions, feel free to ask in the comments below. Thank you. So, as we have learned a bit about Stack, what it really is, what are its applications, what are its advantages and disadvantages, now we'll create a project implementing Stack. So, to begin with, we're going to make a task management system using Stack. So, for that, we need three files. First one of them is the main code file itself, which we are going to name main.py. After that, we need a log file to dump all our logs, what are operations we did. So, log.txt. Then we'll have another file known as task.csv. CSV we're using to dump everything, all the things we have as a task into one file that will store everything. So we are done with the basic thing. Now we'll go into the main file and write the source code. So to begin with, we need to import some modules, which will be datetime, which is a default library, which comes included with a Python package. Then we will use plier. The basic function of plier is to show notifications to Windows, and this we have to install using pip. Then we'll use CSV and getPass. getPass for authentication, CSV for dumping data into CSV file. Then we'll use term color to give a color kernel different color when it outputs. So we'll begin with importing our modules. So as you can see, we've imported notification from player, date time from date time, term color, and term color we have imported color. So all of these are functions that are included from that are exported from a certain library. So moving forward, we'll have a class named as task as a main class. So in this class, we have a function which will be initializing. We'll pass a self parameter in it, then title, due date, and priority. So this is the main class, and now be going to declare them. So now we have defined the main functions. Now we'll move to another function, which is str. Now here we'll be passing the self parameter that we had created before. Now here we'll be using conditional formatting to print. So now we're done with this function itself and move forward. Now here we'll define another class known as task stacks. Non-task stack will now again initialize, and here we pass self with name. Now we declare the functions that just made. Then we have this, where this is an empty stack that we'll be using forward. Now, as we've created an empty stack in self.task, we've assigned it a variable through self. Now we'll assign it the push function. Now we'll have another function pop. We'll pass the again the self parameter in it. So the code is quite long and I've written before, so I remember it. So I'll see you once we write the entire code, and I'll show you the demonstration first and then explain the entire code. Hi everyone. As you can see, we've written the entire code. So now I'll demonstrate to you the entire code. It's working, and then we'll learn what the code actually is. So now as I've written the code, here's a demonstration of how the code functions and works. Here my username is Japjot, which is going with my name. So now we have the following menus, two options to add and delete tasks. Suppose you want to add a task and complete the project. Description for which will go into DSA task. Task description is to complete DSA task. Due date is for today. Today the due date is 2025. Priority, I'll set it for high. So suppose I've done it now and now I want to print the task. So what I'll do is display 5. Priority, high. Due date 2024. The thing now is I've disabled notifications because of which we couldn't get an option for the notification. As we enable that, let's do it again. Here now we get due date, complete project is due today. So the apply functionality enables me to print the function on the menu while it showed in a color completed project, height, due date, this. And now suppose I want to move the task to different stack from to in progress, from in progress to completed. I'll go with one now. Then I'll again move it. Wait, I'll just first print and check if it comes. Now it is an in progress and it is in yellow. So I'll again move it and see where it stands. Complete project, priority high, due date 2024, 5. So now it's in cyan color. So this shows that the code moves. And suppose I want to delete this task now. Enter the stack from which to delete the task. So now it is completed for this time. Deleted task, start completed project. So now if I just check, there is no stack, no task in any stack here. So I think so we're done with this is and the code works perfectly. So I'll add another task here again. Suppose record the video. Description is record for the due date. I'll set it again for today. So to just check that we have the task here. Yes, we have the task here ready with us. So now we'll save it in the CSV file. So as we can see, it is perfectly saved. And now we're going to the log file. The log file also works. So this shows that our code works properly. So thank you everyone. So hi guys, as we have learned what Stack really is, what are its applications, what Stack is, what are its advantages, what are its disadvantages. Now let's learn about a program where Stack is implemented. For first and foremost, we need a log.txt file to First and foremost, we need a log.txt file to dump our logs, our operations. Then we need a task.tsv file, dump our task into. And now let's look at the code. In the code, we have basically datetime function imported, which is the default Python library. Then we use plier, which is installed using pip, and then CSV and getPass. And term color is again installed using pip. Term color is a library to color the kernel, while plier is used to display notifications. Now we have multiple classes defined in the program. Moving forward to the first one, class task. Here we initialize and pass a self parameter along with title, description, due date, and priority in it. Then we assign them as values. Next we have the string class where we return self function, and then here we assign the priority. as an input, set the title, priority, and save due date. Then we have another text tag, task tag, where we initialize and give the values self.name. We assign self.task and an empty stack here, and then we push values into it by the parameter push, by the function push. Self.task append the task, then pop. Pop is used to delete. First, we check if the stack is empty, if the function is empty or not, and then if it's not, we pop it. To check, what we do is we check the length of the stack in its entirety, and then if its length is equal to 0, then we print it's empty. The function is called on later. Then we have another class named the task management system. Here we initialize and give it the self value, and then we have three main stacks here: task stacks, to do, in progress, and completed. And here we assign them as values. Then we assign that the self current user is none here. We assume that there is no user at the beginning. And then after that we call it for authentication. And also like load task from CSV. The main purpose for that is to load data from the CSV for existing stacks whenever the program is started. Then we write the authenticated user program. So first it prints user authentication and takes the input, and using get pass, what it does it verifies if the name and the username and password is exactly equal to the one specified in the code. Then it starts authentication and moves forward, else it exits you from the main code itself. Then we have the add task menu, where task and stack are called, and we push them into the main stack. Then we also can move our data from one stack to another. Suppose if there is a task and you have and the process of completed it. So from beginning you got it into in progress, and when you completed it, you move it into the completed one. Then you've got the edit task here. In edit task, you print the menu, and like if you want to edit, you can edit the title, description, due date, and priority using the choice menu option. And if there is a one choice, then it decides to append the choice that you made. Then we've got delete stack here. If you want to delete the stack, what it does it declares and pops the function. Pop is defined earlier here and is a defined method of the stack function. And then it prints it as well. That this is a deleted task and a deleted title. And then if the stack is empty, it prints the stack is empty. And if you want to display the task, the thing is it does is it prints an green color, which is used here because of the term color library. Then if it is in progress, it gives in yellow. If it is completed, cyan is the color used. So this is done here to distinguish between all three categories because of term color. Then, if you want to notify a task, we use a plier. An strft time is a function of the plier library. So, if the task due date, the date we have assigned is the one which matches today, it prints the task title along with the statement that this task is due for today. And then it does a timer of 10 seconds maximum. It will display for 10 seconds and then it will look by itself. Then, save task to CSV. When you give a task, when you define a task, what it does it defines it in the CSV file that yeah, on this date, this description, this time with this priority, it is entered in this stack. And then it writes everything. When you open a program, suppose every day you open a program and every day you assign it a task. Now you need to assign and operate tasks that were put on another date, but they'll come in a day forward. So then you have to load it. For that, we have defined load task from CSV. And what it does it opens this CSV file in read mode and assigns it a header. And for that, it prints. It will date matches today, so its portion pops. And if the file is not there, then it creates it while saving tasks for the next time onwards. Then next function defined is log event. It opens the log.txt file in the pen mode, and with the timestamp and HTML time, it writes a timestamp in the event which is done. Now here comes the main part. If the name is main, task manager, task management system, where we start calling the entire functions using recursion, and then while it's true, it operates and prints the main menu. Here we have the options as add task, move task, edit task, delete task, display task, and notify due task, and save task to CSV and exit. And then it takes a choice using a menu one. If the choice is same, what it does is based on the priority and everything, it takes the values from it and then saves it. Here it is all by designed for the choice, and it calls basically the stacks and everything, and the function defined for everything. Suppose we want to move it, then what we'll do is task manager to do stop, task manager in progress stack. From to do to in progress. This is for that. If choice is one enter, to do moving one. If the choice is two, what it does is from in progress to completed. And that's for that, and so and so. If choice is three. So this was a function to display the task. If you want to enter that, then if it has an invalid index, it prints that, and it also writes in the log file itself sequentially. Then we have choice is equal to 4, which displays a star, and it is the main function of this one is to delete the stack from to do import or completed. Suppose if you have the task is cancelled. Suppose I have a test tomorrow and the test is cancelled, so I can delete to this one. Then I have the choice is equal to 5, which is used to display task and then notify them. It will date matches to today, and then log event writes it side by side. Then suppose I'm done for today and I have to save all the things that I've done in the CSV file. Then 6 is the choice for me, and then I want to exit, so it's 7. If you give any other choice, it exits. That's it. Thank you, everyone. Hope you have a nice day ahead, and I hope you have learned a lot about Stack through this project. Make sure to like, subscribe, and comment on the